All right. So, okay. So here's what we're going to do. I'm going to go through a few of the problems that I sent out for NTI days 13 and 14, just as a kind of a reminder of how to handle similar triangles and how to prove them, how to prove similar. As a way of refresher, I'm going to switch to here and show you okay, so you should be able to see the NTI Day 13 and 14 assignment in front of you. I'm not going to go through all 10 of these, but I'm going to pick out a few of them just as reminders as to how similar triangles work. And so look at question number 3. Scale factor, that's probably the most basic part of similar triangles. They're related to each other by a scale factor, and it says the scale factor A to B, so we that ratio as A over B is over 5. So what that means is everything associated with triangle A is related to this 4, everything associated to B is related to this 5, and the X comes from triangle A. We're going to put it on top where the A is, the 15 is on the bottom where B is, and now we just solve this by cross multiplying. X times 5 gives us 5x, and 4 15 gives us 60. Solve that. We'll just divide both sides by 5. And that says x is equal to 12. And unfortunately, I keep getting webcam advertisements for Facebook, so my webcam may poop out. But anyway, that's number 3, and that's how scale factors work. The scale factor for one triangle, all of those dimensions go on top. For triangle B, all of those side lengths would go on the bottom if we were trying to find out something other than x. I'm not going to solve question 4, but I will remind you that the perimeter is made up of the lengths of the sides. So the perimeter of KLM here is just 6 plus 15 plus 12. You can set up a ratio where the perimeter of this guy is the unknown, call it P. So you can solve that question very similar to the way we did number 3 here, where P is the unknown, and the known is not the length of one side, but it's the length of all 3 added together. Use that scale factor to help you find the perimeter of an unknown triangle. So that's kind of a refresher on scale factor. So if you flip over to the second page, a couple of questions we'll look at. But first, let me do this. There are 3 ways that we prove triangles similar. The first one is AA, or angle-angle. In other words, we can look at 2 triangles, and if we know that there's one pair of angles congruent and another pair of angles congruent, we can say that this triangle ABC is similar to LMN by angle-angle when there are 2 pairs, because angle A is congruent to angle L, and angle C is congruent to angle M. Then by the angle-angle postulate, those 2 triangles are similar, and we would write the similarity statement ABC is similar to triangle, and then we have to match up because these correspond. A corresponds with L, so L goes first. M corresponds with C, so it's going to go last. So it's going to go last, and N would go second. So ABC is similar to triangle LNM. So that's one of the three ways. The third way, or the second way, is side, side, side. And it's probably the easiest as long as we remember one very simple fact. We've got A, B, C here, and L, M, N, N. When we were looking at congruent triangles, then this side might be congruent to that side. Well, it's not congruence anymore. It is the ratio of the sides that's most important now. So what I'm looking for is, for example, the ratio of AB to LN be equal to the ratio of BC over NM, and that's equal to the ratio of AC over LM. If those three ratios are all equal to each other, then these two triangles are similar. ABC is similar to triangle LNM by side, side, side. Okay, but the ratios have to be equal, not the individual side lengths. I have no idea that I'm pretty sure that AB is not the same length as LN, but what's important is the ratios of the two are the same. Third way is another one that may sound familiar, side angle side. Let me draw some triangles that might look a little different here. Side angle side says if I've got A, B, C, and X, Y, Z, then for an included angle, we'll say it's A and X. Those two are congruent. Angle A is congruent to angle X. What I'm also looking for is that the adjacent sides, side and say this side, the ratio of those two sides would be equal to the ratio of these two. So what that would look like is the ratio of AC over XY is equal to the ratio of AB over XZ. And if that's true, then we can say that triangle ABC similar to triangle, I make sure I get this right, X, ABC, XZY in this case, XZY. Right, because A and B and X and Z go together, A and C, and yeah. Side, angle, side. And so what we're looking at again is we're looking at two angles and the adjacent sides are in the same proportion. Okay, so those are the three ways that we prove triangles congruent. So with that in mind, let's go back and look at question 6 here. Is triangle AXB is the big triangle similar to ZYX. I'm sorry, yeah, ZYX. That's the smaller triangle. So the first thing we notice is that both of them share angle X. So we can say that angle X is congruent to angle X by the reflexive property. by the reflexive property. So that gives us the angle that we need. Use side, side, side here because I don't know anything about the side lengths. And so I can't use side angle side for the same reason. So either these two triangles are not similar or I have to use angle, angle. Well, I've already got one angle or one pair of angles, quote unquote, one pair of angles similar or congruent. All I need is another pair. And so I can get that if I remember symbols here mean that AB parallel to YZ. And if those two lines are parallel, then they're cut by a transversal. And so angle A to angle Y, because they are and so now I can say because of that, angle A is congruent to angle Y. And now I have two angles congruent. So these two triangles are similar by the angle-angle postulate. Okay, so that's number 6. Let's look down at number 7. Which pair of angles can be proved by the side-side-side theorem? Well, if I look at A and D, I don't know anything about the lengths of any of the sides. So I can use that for that one. So let's look at C. I do know something about all the lengths of the sides for C. And so to use the side-side theorem, then what I'm looking for is the ratio of these three, of the three pairs of sides to be equal to each other. In other words, the ratio of the short side, which in the triangle is PN, the ratio of PN over the short side here, LW, has to be equal to the ratio of the middle side, which is PX over here. And the middle side here is AW, and that has to be equal to the ratio of the long side, XM, and the long side here is AF. Okay, so now I'm going to double check that. PM is 9. LW is PX is 12. AW is 16. And XM is 15. And AL is 20. So the question is, are those three all equal? Well, if I simplify them to lowest terms, this one reduces to 3 over 4 by factoring out a 3. This one reduces to 3 over 4 by factoring out a 4. And this one is 3 over 4 by factoring out a 5. So those proportions are all equal to the same value, which is called the scale factor. So I say confidently that I can say those two triangles are similar by side, side, side. The ratios of the three pairs of corresponding sides are similar. Okay, I've got one more example and then I'll be done. Look down here at number 10. We're going to complete the statement, triangle ABC is similar to some other triangle using which similarity theorem? Okay, so ABC is the small triangle. And what I look like, this is a composite triangle here, and these two both share angle A. So I'm thinking that it's either angle, angle, or angle side. So I can eliminate this guy because I don't know anything about the lengths of these two sides. but it could be any of these three. I don't know that these two lines are parallel, so I can't figure out anything about the measures of these angles, so I'm going to eliminate that guy, and I'm going for side angle side here. So what that means is I need to be able to get the ratio of AB over AN to be equal to the ratio of AC over AK. And if that is true, then I can say, hey, these are similar by side angle side. So let's check. The length of B is 8. The length of AN is 8 plus 2, or 10 plus 2 is 10. AC is pretty obviously 12. A now is 12 plus 3. So I still don't know if those are equal yet. So I'm going to keep on simplifying. 8 over 10, 12 over 15. I reduce this to lowest terms, factor out a 2 here. I get 4 over 5. And factor out a 3 here. I get 4 over 5. Those two proportions are equal. I can say that triangle ABC is the triangle ANK by the side angle theorem, or choice B. Okay, so there's that one. And hopefully with these hints, you can go and you can go ahead and finish the other the other 6 of them. Let me come back to the camera now. Well, look who's here. Who joined us? Miss Haley. Hey.
Frozen.
Hi, Mr. McReynolds.
Hey, how are you doing?
I'm just eating French fries.
Please tell me you're not driving.
No, she's being a delinquent
in the parking
lot.
Not
at home, which is supposed to be on quarantine.
Okay, all right, well.
Look who's with me. There's Brittany.
Oh my gosh.
And there's Jordan.
You'll need to be on quarantine in your house.
I don't think you're 6 feet apart, but I guess that's not from
Technically, my car's my house right now.
Oh, okay. Well,
you need to be with your car at your house.
I guess that's permissible. Anyway, so what I want you to do is finish this one, NTI 13 and 14. This is practice, and NTI 15 and 16, which I sent you yesterday. That'll be the actual quiz. The questions look really similar. I changed the names and the sizes and diagrams a little bit. But since this is practice and the other one is the quiz, it will count twice as to what this one counts. So both of them count something, but the main thing is if you get stuck, if you're not sure how to go through here, then stop, send me a message on Classroom. I'll try to get back to you as quickly as I can. If it's still not soaking in, then we'll get one-on-one on video chat just like this, and we'll go through it. But the other main thing is credit. You got to show your work here. Okay, don't just go down through here and circle ACDC, 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 because I know that's what you're listening to while we're on the break. So just make sure you show me some work as you go through here. I left the answer choices on there to kind of be a simple guide to see if you're on the right track. Okay. And so that's it. Any questions?
Yes.
Yes.
No.
Like, hold on. So are we allowed to turn all the work in on May 4th that we did, or do we have to send you pictures through Google Classroom?
Oh my gosh. Okay. You are allowed to do that. Okay.
So I'd rather just turn it in after, like, once I get back.
But what
If
it
we can
means,
go back.
what it means is that you hate me. Because you're going to give me this big giant stack of stuff that I have to grade overnight. Okay. My
What if
preference,
we don't come back?
that's the other thing, is it's becoming,
Then I'll just mail it to you.
you can mail it. You can mail it. You can mail it to the school. On the envelope on the outside, put attention McReynolds, and I'll be happy to do that. I'd be delighted to do that. If it's hard for you because of internet connection or because you're not familiar with working a smartphone and sending pictures over a smartphone, which I know some of you've never done before.
We do it all the time. What are you talking about?
You can mail it, and that's perfectly fine. But please don't wait to May 4th for two reasons. I don't want to have a stack of stuff to grade, on May 4th. Secondly, there's a chance we won't even come back on May 4th. So don't.
I'll just start sending you stuff little at a time.
Nothing makes me happier to hear. Honestly, that's perfectly fine. Perfectly fine.
I'm kind of mad that not a lot of people are in here right now.
I am too, really. I'm a little disappointed.
Hey, I totally forgot about it until Remy texted me.
I texted everybody in the class, and Raven's just now texted me back. She said, "What time?" I said, "The class is already over."
Yeah.
So when are you going to do this class again, so I can remind all these lovely people that don't like to stay home?
I'll probably pick a time on Thursday. Since there weren't very many on here, but we'll probably get together again on Thursday.
Okay.
Okay.
And it's kind of hard because this is the stuff we reviewed in class, but my binder is at the school with all my notes in it.
Oh yeah.
So I have a really bad memory. So I have to look at the videos over and over again and then go back to the work on my phone. It's hard.
Well,
Yeah, well, you go to Pilot Rock and get on high elevation like almost every day. Losing you.
I've only been twice, Remy. Twice.
Like 5 times. I swear it was 5.